In this lesson, we're going to look at solving quadratic equations using factoring. And when we're solving a quadratic equation, what we're doing is we have our quadratic equation in the form ax squared plus bx plus c, and it's set equal to 0. And what we want to do to solve this kind of equation is we want to find the factors that would make up, if we multiplied them together, would give us this quadratic equation. Let's assume, for example, that a equals 1. If a is equal to 1, then this quadratic equation would factor, if it was also factorable, would factor into x plus m times x plus n. And that would equal 0. And if we got this far, we could say that there are two possibilities. Either our first binomial, x plus m, equals 0, or our second binomial, x plus n, is equal to 0. One or both of these could be true to make their product 0, because the zero product property tells us if you multiply anything by 0, the result is 0. So what does this mean? It means we could say that either x plus m is equal to 0, or x plus n is equal to 0. And if we look at this first equation, if we want to solve for x, we want to use the addition postulate or property of equality by adding to both sides of the equation a negative m. That is the additive inverse of m. So if we add a negative m to both sides, then a negative m and a positive m cancel out, and we have that x is equal to negative m. When we look at x plus n equal to 0, and we want to solve for x, we're going to add a negative n to both sides of the equation to keep it balanced. So x plus 2x plus n, we add a negative n, and we add a negative n to the right-hand side to keep it balanced. And a negative n plus a positive n cancel out, and we end up with x equals negative n. So our possible solutions for x are that x can equal either negative m or negative n. And we should certainly check our solutions. So let's try this with an example. Here we have a sample problem. This is a quadratic trinomial, and it's set equal to 0. We want to find out which values of x would solve this equation such that the left-hand side is equal to 0, which is what the right-hand side is equal to. What we want to do is we want to factor this. Are there two numbers? Well, let's take a look at a, b, and c first. A is 1, b is 8, and c is 15. What are the two numbers, m and n, such that if you add them together, you get b, which is 8. And the same m and n values, if we multiply them by each other, we'll get c, which is 15. We can certainly check this by factoring 15. 15 is 1 times 15. 1 plus 15 is 16, so that's not going to work. 15 is not equal to 2 times anything. 2 does not go into 15, but 3 does. 15 is equal to 3 times 5. 3 times 5 is 15, and 3 plus 5 is 8, so our m and n values are 3 and 5, because 3 plus 5 is 8, and 3 times 5 is 15. Okay, so now we're able to factor this equation that I just moved up. And we factor it into x plus m, which is our 3, times x plus n, which is our 5. Now, what we have is a zero product property. Tells us that if you multiply a value times another value, if one of these values is 0, the product will be 0. So either x plus 3 equals 0 or x plus 5 equals 0. X plus 3 is equal to 0, or x plus 5 is equal to 0. If we want to solve this, looking at our first equation, if I add a negative 3 to both sides, I get x equals negative 3. And in the second equation, if I add a negative 5 to both sides, I get x equals negative 5. So the solution to x, what x is equal to, is negative 3 and negative 5. We should certainly check our solutions by plugging them back into the original equation, and we will see that when x is equal to negative 3 here and here, the left-hand side is equal to 0, which matches the right. And when x is negative 5 and we plug it in here and here, the left-hand side again is equal to 0, which is what the right-hand side is equal to. So the solution to this equation is x is equal to the set of values negative 3 and negative 5. Here's another problem. In this case, we don't have a 0 on the right-hand side. But by adding a negative 12x to both sides, let's take the left-hand side, 3x squared. If we add a negative 12x to the left and a negative 12x to the right, the positive and negative 12x on the right cancel out, and we end up with 3x squared plus a negative 12x is equal to 0. Now looking at this, we see that the right-hand side is equal to 0. Let's factor the left-hand side by pulling out the greatest common factor of 3, x. And we end up with x plus a negative 4. This is now also equal to 0. And if we look at this, 3x times x is 3x squared, and 3x times a negative 4 is a negative 12x. This is where we're going to use a zero product property. Either the first fact, which is 3x, is going to equal 0, or, to make this equation valid, the second fact, which is x plus a negative 4, must equal 0. If either one of these equations is true, then our original equation is true. Let's solve for x. Here, in our first one, we're going to multiply both sides by the multiplicative inverse of 3, and that's 1/3. To keep our equation balanced, we must do it to both sides. 3 times 1/3 is 1. So the left-hand side is x, and the right-hand side is 0 times 1/3, and anything times 0 is 0. So x equals 0. In our second equation, where we say x plus a negative 4 is equal to 0, we're going to add the additive inverse of 4 to both sides to keep it balanced. And we know that 4 plus a negative 4 is 0. That gives us an x on the left and a 4 on the right. So for this equation, original equation, to be true, the values of x that will solve this equation are x is equal to 0 or 4. And we should check our solution by plugging in these values of x into the original equation. When we do, we'll find that both of these solutions are valid solutions. Here's another example. In this example, the right-hand side is not 0. We don't want to factor the left-hand side if the right-hand side is not 0. So to make the right-hand side 0, what we want to do is to both sides we want to add the additive inverse of 4. By adding a negative 4 to both sides, we end up with the following. On the left-hand side, we have x squared plus 10x plus 28 plus a negative 4. We're going to add the negative 4 and the 28. And when we do that, we get a 24. On the right-hand side, because 4 and a negative 4 added together are 0, we get a 0 on the right-hand side. That's what we wanted. Now we can factor the left-hand side. If we factor the left-hand side, we'll find our m and n, such that the sum of m and n is 10, and the product is 24. What are those two numbers? And if you work this out, you'd find the numbers are 4 and 6, because 4 plus 6 is equal to 10, and 4 times 6 is 24. Now we can use the zero product property. If the product of x plus 4 times x plus 6 is 0, then either x plus 4 equals 0 or x plus 6 equals 0. So we say either x plus 4 is equal to 0 or x plus 6 is equal to 0. In our first equation, we can add a negative 4 to both sides, and we get x is equal to a negative 4. In our second equation, we can add a negative 6 to both sides, and we get x is equal to negative 6. So our solution to the original equation here is that x is either equal to a negative 4 or a negative 6. Here I've moved this up. And so what we can do is we can check our answer by plugging in the two values, negative 4 and 6, into our original equation. And when we do, we'll find that both negative 4 and negative 6 are valid solutions to the original equation. Here's another example. Again, the right-hand side is not 0. So what we're going to need to do, let's move this up, is add the additive inverse, which is 11x to both sides. And when we do this, we get 4x squared plus 5x plus the additive inverse of a negative 11x, which is 11x, minus 20 is equal to 0. So what's happened here is I added the positive 11x to the right-hand side and immediately it became 0. Let's move this up. I also want to change this subtraction to add the opposite. And now I can associate these two middle terms together and add them, and I get 4x squared plus a 16x plus a negative 20. Okay, I've combined like terms on my left-hand side, and the right-hand side is 0. So I need to factor the left-hand side so it's no longer the sum of three terms, but the product of facts. And let's start by factoring out the greatest common factor. I can see that 4 goes evenly into 4, 16, and 20. So what I get is 4 times x squared plus 4x plus negative 5. Now I need to finish by factoring this quadratic trinomial. So I write the 4 that I have, and this quadratic trinomial, since its lead coefficient is 1, factors into x plus m times x plus n, where m plus n is 4 and m times n is negative 5. And what I'm going to get is 5 and negative 1, because a negative 1 plus 5 is 4, and a negative 1 times 5 is a negative 5. Okay, so for this to be true then, the left-hand side must equal 0 if the right-hand side is 0. Well, 4 is not 0, but x plus a negative 1 could equal 0, which would cause the whole left-hand side to be 0 because multiplication by 0 is always 0. Or the x plus 5 could be 0. So one of two situations is true. Either x plus 1 is equal to 0, or x plus 5 is equal to 0. Our left-hand equation, we'll add 1 to both sides, and we get either x is 1, that's our left-hand equation, excuse me, and in our right-hand equation, if we add a negative 5 to both sides, we get x is negative 5. So the solution to the original equation is that x is either equal to 1 or negative 5, and we should certainly plug these in to the original equation to double check, and we will find that in fact our solutions are negative 5 and positive 1.